So welcome everybody to my talk, Demystifying RxJS Operators. And I really like doing this talk on conferences because in my daily job as consultant, I often stumble across this very common pattern, like particularly in Angular applications, most of the developers are fairly, are often using operators on a regular basis for their applications, whether it's inside their components or if they're working with NGUPEx or whatever in the effects. Doesn't really matter. There are a lot of operators out there in business application, but it's surprisingly how often people don't really know about that. And it's kind of a good thing that we have this good level of abstraction that is not needed to know it. But I promise you, understanding about those operators will help you in your experience with RxJS. So when I don't know about something as a professional consultant, the first thing I do is go to Wikipedia. And when you look up for an operator on Wikipedia, it says something like this. An operator is generally a mapping that acts on an element of a space to produce elements of another space. While this is a fairly mathematical explanation on operators and more about additions and stuff like that, concerned about those, but it applies surprisingly well for RxJS operators as well, as RxJS operators are usually applied on observables to change behavior, change values, and produce therefore elements of another space. Before we dive deeper into that, let me introduce me properly. My name is Jan-Niklas Wortmann. I'm a consultant for Evora IT. I'm a member of the RxJS Core Team since mid of 2018, and I'm also an Angular GDE. One thing is left before we go into the talk itself. What I want to mention is that some of the things I show you today are heavy implementation details. It's still good to know about this, as this is how RxJS is defined right now. It's not good to rely on those, as things might change. Okay, operators, RxJS, and a little bit of TypeScript maybe. So when we look at the RxJS code base, we'll stumble across those three interfaces that basically defines the shape of an operator. So we have the unary function that is basically just describing the pattern, the shape of the function itself. So it's a function that takes a function as argument and which takes a source of whatever type and returns something else of another type. If we apply this to an operator function, this is the same thing just for observables. So an operator function is a function that takes a function which takes a source observable and returns another observable. And on top of that, we also have, as a little bit of a convenience, the monotype operator function. Imagine operators that don't change the output type. So for example, filter just filters out the value but returns the same observable type. Therefore, you have the same type, so you don't need to have a different output type specified. This is still very technical. I want to take a step back and talk a little bit about the definition of operators. And I know the RxJS documentation is lacking this information a little bit, but from my point of view, an operator is defined by two key criteria that needs to be fulfilled. And one of them is that it has to be composable, and the other is it has to add behavior to some extent. What does that mean? So let me do this by some examples. Map is a really, really good example for a common operator, right? So we have this function that we can apply on every observable that we want. It takes a production function that we then apply on every element to create a new element. And therefore, we return a new observable. From my point of view, is not an operator because it does not add behavior to an existing observable. It creates a new observable. And on top of that, it's also not composable, as you cannot call from, right? You cannot pipe it. Multicast is one of the tricky bits. So if we take a deeper look into multicast, in the signature shown here, it returns a connectable observable. A connectable observable, you need to call connect on it so that the subject instance under the hood connects to the source observable. Therefore, it's though not composable, as you have to call connect and cannot apply other operators to it. If you use another signature where we have specified a selector function, out of nowhere, we now have the return type of observed value of, which is just a convenience. In the end, it's still an observable and not a connectable observable anymore. And this signature of multicast can be considered an operator from my point of view. To sum this up, an operator has 6 responsibilities. So every operator provided by RxJS needs to fulfill these 6 criteria. It has to handle the next error and complete emission, and even if it's just passing through those. So imagine map. Map is handling the next emission and then passing through error and complete. It does not manipulate those, but it still needs to ensure that other operator afterwards, which could catch those, can react appropriately. It also has to handle subscription and unsubscription to the source observable, and last but not least, returning a new observable, so that we work to some extent in an immutable way. Okay, basic understanding, common ground is built up now. Now let's talk about the pipe architecture that was established by RxJS 5.5. So taking back going back to the operator signature, so it's still a source observable, a function that takes a source observable, returning a new observable. If you consider this, then we can write code like shown here on the left side. This is the way we are used to it by now. Like we're having we create an observable from some static values, we call map to, and some other operators in the pipe method. And those are called sequentially. If we consider that we can pass the source observable as argument to an operator, this way we can completely invert our function call to write code like this. So we can apply the tab operator as the very first. To this we take map, and to this one we pass from. And the way JavaScript works, the function call is from the inner to the outer. Therefore, behavior is the same, just that no one is able to read and comprehend this kind of code. But this explains really well what the pipe method is actually doing. So the pipe method is actually, this is the pipe method extracted from RxJS with some minor performance benefits that we have in the RxJS code base that is not necessarily here for the explaining the pipe method. But it's in the end, it's a big reduced statement over all the operators that are passed to that function. And then we call them in order and always take the return value and pass it to the next operator in the chain. The pipe architecture was originally and mainly introduced to guarantee tree shakeability of the library itself. If you remember, we might remember before that we have had prototype patching, which is still barely tree shakeable. Therefore, we changed that approach that we now have to have dedicated imports for the operators that you want to use in your code base. Another benefit is that we improve the readability from my point of view. Compared to this inverted function call, it's a huge benefit, even though prototype patching was kind of similar from the function signature. The last thing that is actually not that commonly used, but still a huge benefit, is that the pipe architecture improved the extensibility of the library immense. You're now able to just specify a function that adjusts, that is according to the certain shape that implements this interface, and you can use that operator on your own in your whole code base. And we will actually take a look how custom operators work and how they are looking like. I want to take a step back and talk about this statement again. Every operator returns a new observable. If this is true, we can write code like shown here, where we usually, when we're using subject instance, we are tending to use always as observable to remove the observer part of it and just have the observable, right? If this is actually true, that every operator returns a new observable, then we can also just do this, right? So we can just specify the subject instance here, passing it to take until everything will anyway just return a new observable, right? In theory, this sounds good. In daily life, this is a little bit more complex. So if we take a look at those at runtime, particularly on the right side, we see that on runtime, our value here, even though we applied an operator, is an anonymous subject, but our compiler will tell us that it's observable. How can that be? So this is actually originated by the lift architecture. So let's talk about this a little bit. And the lift architecture consists out of 3 essential parts. So we have the call of source.lift, we have the operator class, and the operator subscriber. So I want to explain the lift architecture by going through the basic example of how the map operator in RxJS is implemented. And the map operator in RxJS is pretty much implemented like this. So if you go to map.ts in the RxJS code base, you will see this piece of code. And we see our map operator is a function that returns a function, which then calls source.lift and passes the map operator. Source is an observable, therefore there needs to be a lift method in the observable class. Let's take a look into this. So the lift method is basically creating a new observable and returning that. Therefore, every operator that uses the lift method returns a new observable. Check. Additionally, it also calls setting two meta attributes, operator and source. And those, particularly the operator meta attribute, is later used in the subscribe call. This way, RxJS guarantees to be lazily evaluated. This way, we are specifying here just the reference to the operator class. Therefore, in the subscribe, we then can call the operators in the order which is specified. The operator class is defined by an interface itself. And this interface just defines a call method. So every operator class has to implement a call method that is then later used in the subscribe method. And here we see that it has to pass a subscriber and the source observable and returns a tear down logic. So back to our map operator. We see here in our constructor that actually we see all the values that the map operator supports. We see the projection function, and on top of that, we see the specification of this argument, which is barely used, but technically supported by RxJS. Then the interesting part happens in the call method. So the call method, here we are calling source.subscribe. This is where we are subscribing to our source observable, and we're passing the map subscriber. The map subscriber is then responsible for handling the logic of the map operator itself. How does this look? This might be a little bit tiny, and I'm sorry for that, but it's actually really one-to-one the code from the RxJS operator, from the RxJS code base. So the first thing is that it extends subscriber. This guarantees that even though an operator is entirely empty, it will just pass through all the emissions. So next, error, and complete are just passed through so that later operators can still react to that and work appropriately. The other thing then is that we override the next method. And this next method is then handling the next emission, applying or calling the projection function in a try-catch block, because imagine inside the map operator, the function that you passed throws an error. This way we can ensure that we catch this and redirect it to the error channel of the observable. And lastly, we just emit, in case there was no error, we emit the result of the function passed to the map operator. This still explains the concept of the lift architecture. Due to a recent pull request of Ben where he tried to minify, or no, he actually minified RxJS a lot, the code might look a little bit different by now. But it still gives a good overview how lift is implemented, how RxJS leverages that, and the reasons behind that. Back to the statement. So why, if we have calling an operator on a subject, at compile time we get an observable, but at runtime we get a subject. Why is this the case? Well, I mentioned that observable implements a lift method that is then called later on. Actually, subject also implements a lift method. Therefore, from all the type signature, it works as the subject class extends observable, right? But on the other hand, by providing its own lift method, it still works the way it is. And we see here that we're creating an anonymous subject and returning this at the end of the lift method. This is exactly the reason why at runtime you will get a subject instance out of the pipe method. Benefits of using the lift architecture. The original reason, so the lift method or the lift architecture was introduced with the RxJS 5. And the original reason for that was a huge performance boost over the way RxJS 4 worked. This is mainly a reason for how the V8 engine worked, but it came with another reason, and this is also the reason why it's still in place the way it is. And this one is customizability, difficult word. What does that mean? So technically, this lift method allows you to create own observable types on your own. So what you can do is you can extend observable to create, for example, your own log observable that logs every operator. I show this code here. So every operator that is passed to the log observable is again wrapped in a log operator, for example. This log operator then adds nice meta attributes to the subscriber, like the operator name and stuff like that. And in the subscriber, lastly, what I do is I'm checking all the channels and emits what's coming in there. How does this look? So I can create my new log observable by new log observable, apply some operators, and in the console output, you will see like what channel was it emitted by what operator, what value was it, and so on and so forth. Please don't be confused by the do operator here. This is actually because the operator class for the tab operator, tab used to be called do, but due to RxJS 5.5, we had to rename it to tab, and the operator class was renamed. So this is the reason why they're staying do. I cannot talk about operators without saving some time for talking about custom operators. So from my point of view, there are two big kind of categories about different kind of custom operators. We have the convenient operators and we have greenfield operators. And let's talk first about convenient operators. So convenient operators. Everyone as developer is known to create constant values, right? So instead of having magic strings or magic numbers, we give it a name to make it easier to read, right? And actually the same concept applies to functions. So instead of having like a huge piece of different custom logic, we group it in a function so that the reader of the code knows like, okay, this does this and that. And then you can take a look into the actual implementation. For some reason, though, this concept is not applied to reduce fairly often. So even though we can pass a named function to reduce statements, barely anyone does that. And I wrote this code, and I'm barely anymore able to do what it does within certain minutes. And it's getting even worse for RxJS code. This is ridiculous. And that's code I wrote. That's exactly my reaction when I revisit this piece of code. And I'm pretty sure it's still running like this in production and no one wants to touch it. What I can recommend to you is to give operators, anonymous functions, or groups of operators that you use on a common basis a proper name. And actually, RxJS does this under the hood. So start with is just a convenient operator to use concat. So it applies concat with a static value and then your source observable. So it starts with a static value and then your source observable. Concat map is the same as merge map with a concurrency parameter. Share is the same with multicast and ref count with this weird kind of inverted syntax. And what I want to recommend to you is actually doing it for yourself. It will increase readability and error proneness of your application a lot. And here's an example that I wrote, for example, is a save get operator. So when I have HTTP interaction, many people need to consider like, okay, what is the proper flattening strategy? In the talk before by Mike Ryan and Sam Julien, they already talked about mapping strategy, but it's still fairly complex to comprehend that what kind of switch map, merge map, concat map, or exhaust map do I have to use? And this way we say like, if it's a get, do switch map, and the user of this method does not really need to take care of that. And on top of that, for HTTP calls, it's also to consider that you have to apply the error operator on the inner observable. Just to be sure, this is handled by this convenient operator that you can use for your own convenience, and it will reduce a lot of errors already. The other thing is greenfield operators. So if you're doing greenfield operators, RxJS by now provides like 105 different operators, not counting creation functions. I would be super curious to see what you're doing there that cannot be achieved by using other operators. But I'm not here to judge anyone. If there's really the use case that you have to do that, please reach out to me first, because I'm super interested in that use case. And second, check out this talk by Ben Lesh and Tracy Lee of last year's ngconf. They go really in-depth through the process of creating an own operator from scratch and all the pitfalls that you have to consider for that. This is all I got for my talk. I hope you enjoyed it and learned a little bit. The slides are available here. I will also publish them on Twitter afterwards. I want to take one more minute to shamelessly promote a workshop that I do online, not next week, but the week after. So if you want to dive deeper into RxJS, want to ensure you understand RxJS properly, I'm doing a Twitch workshop on the 12th of December at 5 p.m. CET. I would be super excited to see you in the chat popping up and doing RxJS stuff with me. It's going to be super fun. Thank you very much for all your patience and interest in the RxJS topic. I really appreciate it. If you have any question, come to my workshop. Also ask me on Twitter or wherever. I will also be available in the Zoom session for a couple of minutes. So if you have any questions afterwards, I'm available. Thank you very much.